Hi guys, welcome to the first video of the week. This video we're going to be talking about line of best fit and linear regression. So the question to ask you, is there a relationship between the fat grams and the total calories in fast food? Okay, so we have some items over here and we have their fat grams listed and their total calories. So my fat is going to be my X. And my calories is going to be my Y. Okay, so we need to number our axis. So I see that my X values goes up to 34. So I'm going to count by fives. And you should be writing this on your graph as well. And our Y's need to go up to 600. So I'm going to count my Y's by hundreds. Okay. And when we plot, like we saw yesterday with correlation coefficient, we are just going to plot these points. This is not a function as far as I'm not going to connect it. So I'm just going to plot these points in their respective spaces. So as I'm plotting, you should also be plotting. So 9 to 60 is going to go somewhere here. 13, 320 might be somewhere here. 21, 420. Now, all of these are estimates because we're not on an exact spot. 30, 530. 31, 560. 31, 550. Okay, 34, 590, 25, 500, 28, 560, 2440, 300. Okay, so here I have my scatter plot. Now, if I want to write a line of best fit, what a line of best fit is, it's a line that goes through the center of the data to try and hit as many points as possible. But keep in mind, a line of best fit does not have to hit points. Okay, it can hit some, it can hit none, but my goal is to try to get in the center of that data. So I'm going to line up a ruler and draw what I think, well, let me use a much smaller pen mark, sorry. I'm going to draw what I think is the line of best fit. Okay, so that looks about right. So by hand, how we do this is we use a strand of spaghetti or something straight, so I just used a ruler, and position that so the plotted points are as close to that strand or that ruler as possible. Okay. Now you're going to find 2 points that you would think be on the line. So that blue mark is what I think the line of best fit is. So I'm going to figure out 2 points. So I see this point on the line and this point on the line. So that first one is 10, 300. And the second one is 22, 450. Okay, now using those points, we're going to write the equation. So in order to write the equation, we either need the y-intercept and our slope, or we can do point-slope form, which is what I'm going to use. right? So my slope is my change in y over my change in x. My change in y is 150. And my change in x is 12. I'm going to divide those two. And we get 12.5 as our slope. Okay. And remember when we did point slope form the other day, we pick a point. So let's say I pick this as my coordinate, y minus the y value, x minus the x value. Okay, and there's my equation. Now, this is a pretty close equation, and mind you, I estimated where the line of best fit went. But our calculators actually do this for us, and we can get the exact line. So, let's go ahead and do that. I'm going to pause the video for a second, and I'm going to go ahead and follow these steps in my calculator by typing in our data to be x is L1 and y is L2. So go ahead as I'm pausing. You should be entering your data in L1 and L2 also. Okay, so once my data is entered, if we remember from yesterday, we go to Stat, Calc. I'm writing my linear function, and I get these values. Okay, now let's see if it said for us to round to a specific value. And it didn't, so I'm going to say let's round to the nearest hundredth, which is 2 decimal places. So that's going to give us 11.73 and 193.85. We can see from our correlation coefficient, 0.97, that this is a strong correlation. Okay, so I'm going to go ahead and write what we had on the side over here. So we had A was 11.73 and B was 193.85, and then we write that y equals A x plus B. Okay, now these two equations look very different from each other, and we're going to talk about that tomorrow. So please make sure to bring this with you.